So thank you all for coming today. And I just want to warn, if you are a member of LAPSA New York or New Jersey, I'll be giving this talk at your group in January. So that's your opportunity to see something else right now. Okay, so thank you for coming. Thank you for the introduction, Scar. My name is Tom Limoncelli from Google in the New York City office. And I'm going to be talking about our take on DevOps, which is something we've been doing for a long time. It's good to see that it now has a name. We've been calling it SRE, Site Reliability Engineering. Now, before I begin this talk, I want to ask the audience a question. And this question is so important that how you answer it may determine if I can even continue giving the talk. And it's very simple. Do you love the 80s? Who here loves the 80s? Yeah, love the 80s. Didn't so much love the politics, but I love the 80s. I mean, I love everything. I mean, just so much, there's so much to love about the 80s. I love the fashion, right? I love the toys. I mean, Teddy Ruxpin, you're always fun. The television of the 80s. The movies in the 80s, I mean, some of the best movies ever. The music of the 80s was just incredible. In fact, this is how much I love 80s music. This guy here, Rick Astley. Now, for those of you who are not familiar with the term being rickrolled, that's when you send someone a link that's like, hey, check out this sexy picture or whatever, and when they click on it, it's not a sexy picture, it's a video of Rick Astley's song, Never Gonna Give You Up. And this is how much I love the 80s. When the first time I got rickrolled, I clicked on the link, I saw the video, and I knew all the lyrics. I was just dancing and singing along. And then I sent an email, I replied to the person and said, that wasn't a sexy picture. What are you talking about? He's like, Tom, you're so stuck in the 80s. It's incredible. What else did I like about the 80s? Oh, I liked the computers from the 80s. I mean, you know, none of this monoculture. In the 80s, we had all sorts of different shapes and forms of computers, and the software from the 80s. I mean, remember WordStar? Yeah. And what else did I like about the 80s? Oh, yeah, I liked the software development methodology of the 80s. I mean, who's with me on this one, right? Okay, who remembers what it was called? The waterfall method, right. Now, for those of you who don't know the waterfall method, it starts, the analyst talks to the customers and find out what they want and writes this big book and makes copies of the book and hands it to the requirements people. And then they take it and they read it and they write a bunch of requirements and they make a big book and they hand it down to the designers and they read the previous book, write their own book, and hand it down to the implementers who write the code, and then it gets testing, and then it goes to operations and maintenance. And then the customer finally gets to see the software, and they say, you know, that's not exactly what we wanted. And we get, as developers, it was an awesome time to be a developer because you could say, I'm sorry, I implemented what's in the book. And they'd say, but that's not what we'd want. And they'd say, well, you might come from some crazy place where water flows uphill, but here on planet Earth, water falls downhill, so you're screwed. And that's why it was great to be a developer in the 80s. And also, you had shrink wrap software. So not only, so after the waterfall, often you would put the software on floppy disks, and it would be shipped thousands of miles away to customers all over the world, which means as a developer, you didn't really care about the operational aspects because by the time it got to the customer, you had already cashed their check. So again, it's great to be a developer in the 80s. Just to recap, you were producing the software, all the operational aspects were happening way over there with the user. And by operational aspects, I mean things like provisioning, installing, upgrading, maintaining, backup and restore, and scaling the software. So software development is disconnected from operations. great to be a developer. It was also great to be a developer in the 80s because software in the 80s didn't have bugs. It didn't have bugs because bug tracking systems hadn't been invented yet. There were lawsuits. People reported bugs and got threatened to be sued for slander or libel. It was good to be a developer. And then came the 90s. 90s wasn't as good for developers because, I mean, there were a lot of good things in the 90s. I mean, Linux and got its start, and Wi-Fi, and lots of good stuff happened in the 90s. But in the 90s, software moved to the web, and it all went downhill from there. Yeah, because when things moved to the web, things were bad. And not this kind of bad, because that album came out in the 80s and is therefore awesome. But so the way software worked starting in the 90s was we were making web software. So we would still do the waterfall methodology, but then the output would go on a server, and all of our customers would use their browser, if you remember those icons, use their browsers to talk to the server. And the server was owned by the same company that made the software. So now the producer and the operator are in one box, and the user is down here. So operations switched teams. And now we had to start caring about operations. But we were still kind of stuck in our old ways, and we were still using the waterfall methodology. We were just shoehorning it into this new paradigm of web software. So, and it kind of worked. Well, it worked as good as waterfall methodology ever worked, which is it didn't. And so then came the 2000s. And in the 2000s, things really changed. In the 1990s, you were accessing the web via a modem. And so if the website was down, it could be your modem. Speed didn't matter as much because you were only talking to the internet at, 14.4, 28K baud. But also some industry dynamics changed. Competition became really intense. There was a huge pressure to be first to market. And there was also this feature one-upmanship between websites. So to compete in this decade, you had to ship new features. At the same time, reliability started to really matter. We now had cable modems. So you really noticed if a website was down or slow or unreliable. And reliability became a selling point. Remember we used to say as reliable as the phone system? Yeah, we fixed that by moving to VoIP. But now people say things like, as reliable as Google. I mean, how many people, when in the room, if a user has a problem getting onto a website, you first say, well, can you get to Google? And if you can't, then they know it's something else. Now, the problem with wanting to have a high velocity of change, new features constantly, and reliability is these two things are at odds with each other. There is a tension between developers and operations. Developers, they get rated based on change. They're all about shipping new features. Did you ship that new feature? That's when they get the pat on the back. Operations, on the other hand, they are graded by if they're maintaining stability. How's your uptime of your website? Is the service fast? And so as operations people, we get patted on the back if we have stability. And to deal with this, DevOps was born. DevOps is often defined as an umbrella concept that refers to anything that improves the interaction between development and operations. It's about interaction. It's about actually collaboration between development and operations. It's instead of a waterfall where you throw the results down the waterfall to operations, development and operations work together. They have joint responsibility for the reliability and stability and the velocity of change of a website. So let's talk about Google and how I saw things happening at Google. And I didn't invent most of this. A lot of this happened before I came to Google. I didn't invent any of this, actually. I'm not going to take credit. I'm just the messenger. So Google has, we call our system administrators SRE, Site Reliability Engineers. The fact that we changed the title is to remind us constantly that the #1 priority of our system administrators is that the website is available and fast. So the SRE model, the SRE philosophy is, the SRE model is a way of achieving at the same time high velocity, high rate of change, and extreme reliability. And to do this, we had to change everything. We needed a new engineering methodology, new organizational structure, management philosophy, and more. So in a nutshell, you can kind of look at SRE 2 different ways. The first way is the developers run their own service. So if you're the developers for the spell checker service, or which is one component of many larger services, or a service like Gmail, when the product is new, developers run it themselves. The SRE team creates tools that enable this. And this is really important because we can never possibly hire enough SREs if every product in Google had its own staff of system administrators. So instead, we create this workforce multiplier effect by giving the developers the tools they need to be their own system administrators. Now, some services do get allocated an SRE team. Usually, only high priority services like search and Gmail. But even in that case, originally developers were running it themselves, and they have to run a service for at least 6 months before they can even apply to be on the waiting list for SRE support. And then they go through a handoff readiness review, and once they've gone through that, then SREs are running their service for them, which I shouldn't say for them. Then it becomes a collaborative process, and SREs are handling most of the operational tasks and collaborating with the developers who are handling the development tasks. And an interesting dynamic here is if things start to get unstable due to developer-related reasons, the SREs can push back and give operational responsibilities back to the developers. So I'm going to talk about a couple things now. How that transition is made if you're lucky enough to get full-time SRE support, as well as some practices that when the teams are collaborative, some policies we have in place to maintain a really good balance of power and, well, you'll see. So how do you make the transition? Let's say you've created a service. So on this graph, you see stability. This is a measurement of stability over time. So let's say you're a development group and you start writing code, and when stability is awful at the beginning because there's 0 lines of code. And you start writing code and code and code, and you have features, and then you say, I think we are ready to get SRE support. And you put your name in the queue, and let's say you do get SRE support. You don't, the transition doesn't happen automatically. First, we have the launch readiness review. Launch readiness review is a checklist of things because SRE is only willing to take over your service if it meets our very high standards. So the launch readiness review is a checklist of things, and developers are often surprised to find out how many no's they have on the checklist. But the SREs and the developers work together fixing those issues, and eventually stability gets better and better and better, and now they are really ready for a launch. So the launch happens, and now live traffic from the world is going to their service. And so live customers. And, oh, I'm sorry, I jumped ahead. I'm sorry. This is, the developers think that it's ready to go live, and you can't go live without the launch readiness review, which is a checklist, and you work with SREs just to get through that checklist and go live. But you're still running, the developers are still running the service themselves. Let's assume that now we've gone 6 months of self-running, and now we've gotten in the queue to get SRE support. To go from self-run to SRE run, there's the handoff readiness review, which is actually the exact same checklist. The questions are the same, the answers are different. We just have much higher tolerances for the answers. So you work together with the SRE team now with the much higher tolerance answers, get it up to be more stable, and now you do the actual handoff. Now SRE is in charge of the operations, and development is more of a tier 3 kind of position as far as operations are concerned. So now the SREs are running it, and they're doing things to improve stability. Their various tweaks and their expertise comes into play, and things do get a little more stable. An important point, though, is as new software releases come out, each time there's a software release, it might be a little less stable or more stable. And so over the next couple months, stability is trending towards being better, but there is some variation. So what would happen if things went really sour and you needed to hand back the service to developers? And this happens very rarely, but it does happen. So let's say stability went very bad, there would be a handoff, and then we return to that handoff readiness review checklist, and the SREs work with the developers to get them back to the point where SREs will take on the operations. So what kind of services do get SRE allocation? It has to have a low operational burden. In other words, the developers had to have done their homework. It has to be very high importance to the company. Sometimes it's done because there's regulatory requirements, like Sarbanes-Oxley requirements that have a separation of duties. And the last point is the most important, SRE availability. Usually people stay on the waiting list for a long time until there's an SRE team available. What's in the handoff readiness review? We look at the type and frequency of alerts that the monitoring system is pulling up. If there's a lot of false negatives, that's a red flag. Or false positive, that's a flag. If we call them spammy alerts, just alerts that are too chatty. We look at the maturity of their monitoring infrastructure. Have they built nice dashboards so that when there is a problem, you can look at the dashboard and get an overall view of things? There's an architecture review. We look at their release process. We look at bug counts and severities. If there's a zillion priority 0 bugs, that's a red flag. And a lot of different things that we can just put in a group called production hygiene. So are you, taking care of business? Are you brushing your teeth? So it's a long checklist. What we found is that the services that have been approved the fastest, the services that have gotten through the checklist the fastest, are the ones that worked with SREs from the early design stages. And it's relatively easy to get SREs to volunteer to help you look at and review the architecture of an early stage project. And now actually we have some formalities around that. There's actual sort of a committee you can go to for suggestions. So what makes all of this possible? I mentioned before we had to change things in engineering and management and organizational structure. There's definitely a lot of organizational prerequisites. The first one, and I think the most important, is you have to have management support. The process of being able to hand back a service to the developers creates a balance of power, and if that does happen, you need management to support the decision. The decision isn't made lightly. You have, and it's never a surprise. I mean, you're working together, the developers know that things are not going well. But these methodologies are supported at the most senior levels of management. Everyone in the management chain understands the importance of operations, not just getting new features out there. The next organizational change is you need SREs with a much higher skill set. Sysadmins that have a much deeper level of engineering issues, an understanding of software development methodology. About About half of our SREs have a software development background and focus on development-related things, and about half of our SREs have an operational background and focus on operational things. So for example, I'm an operations-oriented SRE. I spend 60 or 70% of my time doing operational projects, like moving, like improving the monitoring system, moving a service from one data center to another, operational things. And the rest of my time, I spend writing code to make those operational things easier. Some of the SREs I work with are software development focused. They spend 60 or 70% of their time writing code. It might be tools for me, it might be tools for developers, but they also spend 30 or 40% of their time doing operations, because there's nothing that makes code good, have good operational characteristics than having the developers that wrote it have to maintain it, or have to do the operational aspects also. So I talked about how, for some high priority things, SREs run the service also, but in the general case, developers are their own operational staff. And we make it easy for developers to do this. We provide software tools for everything. Self-service provisioning. A developer can request machines, storage, bandwidth, all in a self-service fashion. They have tools and frameworks that make dealing with failed machines, machine repairs, all that stuff is automated. And even the monitoring system. Most people have a monitoring system where to add a new rule to the monitoring system, you probably need to be root. Our monitoring system is self-service. You can set up your own little monitoring sandbox and totally run it yourself. But a large part of this, making it easy for developers, is also that we provide information resources. So, for example, the launch checklist, it's not a secret. It's up on a wiki page. Everyone can have access to it. So it's not like there's any surprises when you go for your readiness reviews. We also have dedicated launch engineers that do nothing but help people through the launch process. We provide training. There's self-study tutorials and video lectures on all the technologies we provide to developers. We have open office hours. So in all the large buildings, there's a time where you could just sit down and chat with SREs. And in the smaller buildings, we do it by video conference. And all of our tools have a mailing list associated with it for users to join and ask questions. I mentioned before there's there's also different types of SREs, or SREs are involved in different types of services. So I'm an internal SRE. I am an SRE of services that are on the enterprise side of the company. So I do a lot of virtualization work. And there's external SREs that are maintaining services that are either externally accessible or support the externally accessible services. Okay, so we have a lot of policies that drive the right behavior. And I think one of the things I'm most proud of at Google is the way our management is able to come up with policies that make sense and drive the right behavior. One of those is the release engineering policy. So release engineering is you have a new software release, how do you get it out into production? One technique we use is called canary, which refers to a canary in a coal mine. It's, say you're running a server on many different machines, and each of these dots represents a machine. You might only have live traffic running to some of these clusters of machines. Let's say we don't have live traffic running to this first cluster. So we upgrade that first cluster, and we're sending artificial traffic at it. And all of our tests seem to work, so we're ready to send live traffic. So we start upgrading individual machines that are receiving live traffic. And we upgrade a couple, and we test, and we check the monitoring system, and we make sure that those are working. So we upgrade a couple more, and a couple more, and develop confidence with the new release. And eventually, we upgrade larger sets. So I often refer to it as we upgrade one, then we upgrade 1% of the machines, then we upgrade one machine per second until they're all upgraded. And we do more and more upgrades. And now everything's upgraded to the new software release, and it's time to start all over, because by then we have a new release, right? Sometimes it doesn't go well. Sometimes we did everything in testing and it seemed to go well. We start sending live traffic to machines that are upgraded, and it seems to go well, but then some machines start failing. We start seeing 500 errors or just not the results expected. And in this case, we're able to revert back to the previous release and ask the developers for a new release. So we've rejected the release. Developers need to produce a new one. So in the worst case scenario, we start a canary and then we revert it. We get a new release around noon. We start a canary, revert it. Maybe that doesn't work. We start a canary, revert it, start a canary, revert it, start a canary, revert it. And developers are saying, this one for sure. Now, usually, the second one works, hopefully. But you could get into the trap where you're spending your day running yourself ragged with more and more canaries. No matter how much we have automated the canary process, it's still a lot of work, still a lot of stress, and it can get dizzying. It can get dizzying if there's too many releases. And so the developers are saying, no, one more canary. Like this I've reappropriated this XKCD. Are you coming to bed? I can't. This is important. What? The canary is wrong on the Google. Please, just one more release. And the system administrators were sitting there like, 7th canary today? I'm going home. This is crazy, right? So you don't want to get in this situation. So we have a policy that takes care of this, and it creates a great dynamic. We call it the reliability budget. So new pushes are permitted as long as the service stays within your reliability budget. Your reliability budget is based on the SLA, your quarterly SLA. So if you're out of budget, no more pushes. This lets the developers decide, should we just try a couple more releases in rapid succession trying to get it right? Or should we take a breath, maybe wait a couple days, do a lot more, invest in testing, and then do a release? Some developers would like to, maybe this tweak will work, maybe this tweak will work, lots of releases. Some say no, and we as a system administrator, I would prefer them to say, no, we're going to wait a week and really test the hell out of this, right? So let me give you an example of a reliability budget, and these are just fake numbers, but let's say the SLA goal for a service is 99.99%. And so far, we've been doing great. We're 99 at 99.55%. And our monitoring system can really, this is simplifying. Our SLAs are much more complicated than this, and also they're spread over a lot of machines, but this makes the point. So we've been doing pretty well so far. We roll out a canary, and as a result of the canary, we've reduced our SLA a bit. We have, there was an outage that was visible to the way we collect metrics. So now we only have 0.0095% remaining in our reliability budget. Now the developers can decide, based on numbers, should they try just a quick fix or should they invest time in testing? So by using this reliability budget, it puts an incentive to developers that drives them to stability, not just new features. And it also gives the control that the SREs need to permit change and not get caught in the situation where they are the impediment. But most importantly, it makes the whole process numbers-driven, data-driven. So it's not based on politics or feelings. And it pushes the right dynamic. Product management is saying, when is that feature going to ship? When is that feature going to ship? And we, instead of looking like the impediment, we say, do you want that feature to ship? You need to test harder. So it's really important that system administrators are not the impediment to change. And in fact, in our observation, if we've compared teams that do lots of little releases, trying to, lots of tweaks, trying to fix something versus teams that, if they do have a canary revert, spend a lot of time on testing, what we found is more pushes results in more rollbacks. So the velocity is the same if you compare these two teams. So through all of this, we're able to work together. And it's not just policies that make us data-driven, but it's just joint responsibility. Even after full adoption by an SRE team, the developers still are partially, it's a joint responsibility for the uptime SLAs. And the system works. 2 quick test studies or case studies. These are 2 situations that I was a direct observer of. In the first one, the product reached handoff readiness review. We did a gap analysis, so where in the checklist did they get a no? And for each of those no's, we filed a bug. And then over the next couple months, we worked collaboratively to resolve all of those bugs. And at the end of a couple months, handoff was a success. Great. The policy also works when it doesn't work. So in the second example, there was a failure to hand off. So this was a complex batch processing pipeline. And after the handoff readiness review, we did the same thing. We filed a bug for each issue that we found with the checklist. After a couple months, not a lot of those bugs had been fixed. Not a lot of those issues had been resolved. So we kept working together, but eventually we realized that fundamentally this team, which was very successful at maintaining this pipeline, was successful because of repeated pushes and individual heroics. And those 2 things are not values in the SRE team. So after about 3 months of attempts at improving this, the handoff readiness review process was actually abandoned, and we decided that, this team doesn't fit in the SRE methodology. And the developers weren't disappointed. They were actually kind of happy. They said, this is how we like running things. This is how we've made a success. And we said, okay, we have an agreement. So all of this has benefits for both the SREs and the developers. As an SRE, it benefits me because I'm working with developers that are committed to fixing operational issues. It also means I don't have to support a substandard service, something that's unscalable or doesn't handle outages gracefully. For developers, it means that they get better every time they're on a new project. Every time they're on a project that launches, they learn a lot about the realities of operational details. And in their next project, they're better informed. They also have access to SREs and our know-how for monitoring and other tools. But fundamentally, it benefits us both because it eliminates that adversarial relationship that you see at other organizations. So the title of this talk mentions thousands of DevOps. Because our tools are self-service, we empower every development team to work in the DevOps style. So this is every part of the product life cycle that I could think of, from requesting machines to deployment, launch, automatic failover. SRE provides tools in all of these areas and more. And thus making DevOps, it's almost like, this morning I realized we kind of have a franchise kit and empower each development team to kind of franchise their own DevOpsness. And all the tools are based on carrot, not stick. The tools are optional. They could develop their own failover load balancing mechanism, but the lazy path is to use the one we provide. And we always want the lazy path to be the high-performing best practice that SRE is trying to encourage. And we make it easy for the developers. As I mentioned before, we provide a lot of guidance. We provide user guides. We provide code labs. A code lab is a document where you follow the step-by-step instructions and you walk through a real example. You build a Hello World web server and you monitor it, and then you take it down and make sure you get paged and everything. And by the time you get to the end of the code lab, you're pretty expert in the monitoring system, for example. Wow. Okay. That's odd. Okay, so summary so far. Operations has moved from the user to the producer. There's tension between change and stability. Having a joint responsibility for the SLA is what fixes this. And if you can make it easy for developers, you can empower them to do the right thing. And some of the tools for doing that include the launch readiness review, the ability to hand back. To get high velocity and stability at the same time, we have techniques like the reliability budget. We try to hire the best and the brightest and people and system administrators with a development background. And of course, none of it would work without management support. You can do this in your own environment. Empower the developers. Start with, create self-service versions of the things that you do for them. A simple example is setting up like continuous build, continuous test. You can adopt some of these practices. Build your monitoring system so that it can collect detailed SLA metrics and then adopt the reliability budget. And of course, get management support. Ha ha ha, just kidding. Management will never understand any of this. You have to do it grassroots. I think the reason Agile was so successful is Agile is a grassroots development methodology. And so, as mentioned earlier in this conference, one of the most important tools for collaboration, beer and chips. Sit down, start the conversation. Pick one well-defined project that you can work on and build on your success. Lastly, I'd like to talk a little about the difference between management and leadership. Management is a job title. It's something you see on the org chart. Leadership is something we can all do. And as LISA attendees, I think we're all leaders. And I want to empower you to be even better leaders. So what does a manager do? A manager fundamentally is always doing one of three things. They're setting priorities, providing the resources to reach those priorities, and clearing roadblocks. If you're a manager and you find yourself doing any of these three things, pat yourself on the back. You're doing a good job of being a manager. If you're doing something that's not on that list of three things, maybe you're doing something else. Maybe you're micromanaging. Maybe you're getting in the way. So stick to those three things. But as I said before, management is a job title. We can all be leaders. So what is leader? What is technical leadership? I think technical leadership is best represented by the child's game, Follow the Leader. How many people played Follow the Leader when they were little? Okay, so you remember how it goes. The kids stand in a line, the first one is the leader, and you start walking and everyone follows behind you. And maybe you walk, you hop over a brook or something, and as they follow you, they also hop over the brook. And maybe you pass under a low-hanging tree branch, and you lift that tree branch and hand it to the next person, and that person takes the branch and hands it on and on and on. What are the two most essential things that that leader does? Two things. They went first, and they made it easy for others to follow. So they went first. They went under that branch, but they made it easy for others to follow. They showed that by handing it to the next person, we can all go under that branch. And that's very similar to technical leadership. You go first, and you make it easy for others to follow. So maybe you are the person that installed Nagios and created the initial monitoring of your email server, but you made it easy for others to follow. You document, you create a wiki page with some simple instructions on how they too can add rules. Maybe you installed or worked with the lead developer to install a continuous build system, but you made it easy for others to follow. You've added maybe one product to the continuous build system. You've documented how others can do it. Maybe you're a leader by running your meetings better, having a written agenda before the meeting, these basic tool meeting management tips. You go first and make it easy for others to follow. So as a conference that is cutting edge and is often going first, I'd like to encourage you all to think in terms of technical leadership and spread the good word. So thank you. And slides are available on my personal site. Thank you. And now we have time for Q&A. Yes? Actually, could you please come to the mic? Thanks.
Hi. So it wasn't clear to me at what point and why you would go from the developers managing it to SRE management and then back to, and then I understood that if the SREs aren't happy, they would push it back to development, but why would development want SRE to run it if they could otherwise do it themselves?
Oh, why would developers want SREs if they can do it themselves? Okay,
Yeah,
good question.
What service is the SRE providing at that point?
Oh, if they're doing it themselves, what services are they providing? What good are SREs if the developers can do it themselves?
Yeah, and
Right.
if the developers are doing it themselves, they have all these tools,
Right.
then why would they want SRE to get involved?
Okay, so if you're self-sufficient, why would you need SREs to get involved? Well, because you're still carrying the pager and no one likes to be paged at 4 in the morning, so it would be nice to work more collaboratively, and so they can focus on more development stuff. Yeah. Yes?
In your failed example, you had indicated that when you went back and evaluated, you found that the system relied too much on individual heroics. I find a lot that when you're actually in a production environment, that's okay, is what people tend to consider. It's like, we had this release timeline, we got it out, 5 guys had to spend 80 hours of overtime in the week, but we got it out, it's a win, let's move on. How do you combat that cultural ideal?
Okay, so how do you combat individual heroics?
Well, the idea that it's okay.
So individual heroics is okay. I mean, when there's an emergency, you certainly are glad that people step up and take care of things. The question is, do you rely on that as your daily way of doing business? I like to think that the goal of every system administrator is to create a boring environment, because if it's boring, you're not getting the need for individual heroics. So what are some things to do? Good monitoring that can detect things ahead of time on the technical level. Also, it's a reflection of management values. If management rewards not just the individual heroics, but when someone did something that prevents things, that gets recognized. Often as system administrators, we have this visibility paradox where we're only noticed when things are bad. If management notices when things are good, that's much better, or that's very important to changing the culture. One way of doing that is have good monitoring dashboards, for example, so you can see that things are good, and management can look at those dashboards.
Thanks.
I have a couple of questions for you. First is, what is the ratio of SREs to developers?
What's the ratio of SREs to developers? I don't know, but it's...
Just approximately. Is it like
one
SRE to 10 or?
We have, I don't know, I'm guessing more than 10,000 developers and probably maybe 1,000 SREs or less.
Okay. And another question is, can you give a little bit more information of what kind of common systems you mentioned that SREs develop and own? Is it like application monitoring or deployment, or what is it?
Sure, let me go back to that slide. Now some of these aren't directly provided by SREs, but for example, we have a team that provides the development tools, and they're also responsible for like continuous build and integration. So one of the things my team does is we provide a web interface that lets people request machines. So that's one example. Backup and restore, that's, if your application needs backups, there's a library and other code that you can use to point your data to the backup system, and it gets backed up for you. That kind of thing.
Okay. Or maybe in a more direct form, I heard that there is a system Borg. So is it the one owned by SREs or that's owned by dev team?
That's not something, I generally can talk about.
Okay, no worries. And last question, to support these tools, do you have your own development team inside SRE organization?
Do we have our own development team within the SRE organization? We don't have, well, yes and no. Every SRE does some development. Some just are focused on development. But we don't have like a standalone team that just does development.
Okay, and then maybe then one clarifying question. So for your own tools, what kind of methodology do you use to develop them?
Oh, so what kind of software methodology do we use? There's a lot of use of Agile, and other teams are more traditional, but I'd say the majority are Agile.
Mm-hmm. Thank you.
Thank you. Any other questions? Great. Well, thank you. We have, I guess, 15 minutes to the next talk, and, right, am I right? Yeah. Okay, so we'll reconvene in 15 minutes. Thank you.